series of the passive components, which is about inductors. So today we'll be discussing about electrical inductance and inductors. Sir, ano po yung inductance and inductors? As an introduction, we could say inductance is almost the same as capacitance. In what sensor na parehas lang po siya ng capacitance? So inductance is almost the same as capacitance. Ang pinagkaiba lang po nila, inductor does not store the energy directly. Later on, we'll get to know how does the inductor do its job. Ano yung function ng ating inductance para mas ma-comprehend nyo ano yung sinasabi dito na parang katulad lang din naman siya ng capacitor. Pero slightly different in a way. Mamaya malalaman natin yan. And in inductance, the voltage is only produced when the current flowing in the inductor produces the electromagnetic field. Ibig sabihin po, kailangan may kuryente doon sa ating mismong component, which is the inductor. In turn, yung inductor na yun magproduce ng electromagnetic field since may kuryente na siya. After only that, na nagkaroon ng electromagnetic field, dumaan yung kuryente, doon lang po tayo magkakaroon ng voltage. So, pinakamababaw na explanation how inductor works. Kailangan ng kuryente, nadadaloy doon sa inductor. Pag may kuryente na, magkakaroon ng electromagnetic field, and in turn, yung electromagnetic field na yon would produce voltage. Okay? Kung natatandaan nyo, capacitors natin, when we talk about capacitors, supply voltage lang yung kailangan, then yung mag-accumulate yung voltage through the charges, pag nag-equal, yun na yun. That's how you discharge yung capacitor. So dito, kailangan naman natin ng current when it comes to your inductors. So after this, you should be able to define inductors and inductance, identify the different types of inductors, explain yung functions ng inductor, saan ba siya ginagamit, paano siya gumagana, and lastly, we'll be defining transformers, its function, and how it works, and differentiate its classifications as well. So iba-iba po yung mga transformers natin. Mamaya, makikilala pa natin kung sino-sino yung mga transformers na yan. Wait lang ha, mag-change location na ako. Okay. Now, we go with inductance. Sir, ano po yung inductance? Para matapos na yung tanong na yan. So, inductance, paano po natin siya ipapaliwanag in the technical sense? It is a current, nagsisimula sa current, as mentioned earlier. May kuryente tayong involved. A current generated in a conductor by a changing magnetic field is proportional po to the rate of change of the magnetic field. So, key terms na kailangan nating tandaan when it comes to inductance, you have your current. Hindi pa lang naka-pen. Key terms to remember when it comes to inductance, you have current, you have your current and your magnetic field. Okay? So when we talk about current and magnetic field, inductance po yung ating pinag-uusapan. Yung kuryente na dumadaloy na yon and yung changing ng magnetic field relates to your inductance. That is the exact phenomenon of inductance. May kuryente, nagkakaroon ng magnetic field, yung pabago-bago ng magnetic field, depende sa current na binibigay mo, that's your inductance. And it's given by the symbol L. So, napakasimpleng tandaan, inductance L. Pag nakakita kayo ng ganito, so most likely inductance yung pinag-uusapan natin. It is measured in units called the Henry. Kanino po siya pinangalan? American physicist Joseph Henry. So 1 Henry is the amount of inductance required to produce an EMF or electromotive force po ng 1 volt in a conductor when the current in the conductor changes at the rate of 1 ampere per second. Again, 1 Henry is the amount of inductance required to produce a voltage in a conductor kapag nagbabago yung current natin at the rate of 1 ampere per second. So, with this definition ng Henry, makukuha natin yung definition natin ng inductance. Rather, the formula for inductance, which is L equals required to produce an EMF of 1 volt. Ibig sabihin, may voltage tayong involved. We can represent voltage ng inductor natin as VL when the current in a conductor changes at the rate of 1 ampere per second. So, nagbabago po yung current natin at the rate of 1 ampere per second. So, we represent that as dI over dt. Hala, may differentiation. Sir, bakit po kailangan natin mag-differentiate? Di ba ang representation natin ng rate of change much better represented through differentiation ng mga variables. So, again, we represent 1 Henry or yung ating unit of inductance with the production of 1 voltage over the rate of change of current. So, VL over dI over dt. Yung dI over dt natin, again, it's the current variation with respect to time. It specifies how fast the current's magnetic flux is cutting the conductor to produce the voltage. Ayan. The Henry is rather a large unit for use in electronics. So kapag electronics po pinag-uusapan natin, again, usually, ang electronics po ang ginagamit natin dito, small voltages, maliliit na values lang ng amperahe. And with that, hindi natin ginagamit yung Henry, usually for application. Masyado siyang malaki. Ang ginagamit natin, millihenry, microhenry, yun yung mga common nating units na ginagamit when it comes to measuring your inductance. Questions po? And so far? All good?
And so far,
Thumbs up kayo pag ano sa inyo, okay naman sa inyo. Or pag naintindihan nyo, could use your thumbs up. Yan. Okay, proceed tayo. After inductance, syempre, discuss naman natin yung component na nag-exhibit ng inductance. Ito naman po yung tinatawag nating inductors. Ano po sir yung inductor? An inductor is a coil of wire through which electrons move and energy is stored in the resulting magnetic field. Again, when we're talking about inductance, meron po tayo dyang involved na kuryente. And yung kuryente po natin, represented yan ng movement ng electrons. When your electrons move, there is current. Okay? And yung movement na yon, yung action na yun ng electrons natin na brought about by the current, it causes magnetic field, an electromagnetic field. And through that, yung magnetic field na yon, nagkakaroon tayo ng energy stored. So, again, kung babalikan niyo yung previous slides natin, nabanggitan natin ng banggit paulit-ulit, there's a current involved and there's a magnetic field involved when it comes to your inductance and inductors. Inductors store energy in a magnetic field. Hindi po siya sa electric field, sa magnetic field po siya nag-store ng ating energy. One good thing to remember, magnetic field, yung kanyang storing ng energy. Lastly, when the source of electrons is removed, the magnetic field collapses immediately. Since dun nga nagkakaroon ng the cause of the magnetic field itself is yung kuryente. Pag tinanggal mo yung kuryente, automatically mawawala din yung magnetic field. In turn, mawawala din yung storage ng energy ng inductors. So, ano yan? Domino effect. Tanggalin mo yung kuryente, mawawalan ka ng magnetic field, mawawalan ka ng energy stored. So, sa picture, itong picture na makikita nyo, share ko lang, this is the first picture ng ating electromagnet. It's an early electromagnet built by Joseph Henry himself. Sir, ano ba yung picture na yan? Parang napagtripan lang ng bata. Pinuluputan ng wire yung ano ba yun? Magnet parang bakal sa loob. So that's actually the first electromagnet po, or an early electromagnet rather, na ginawa ni Joseph Henry. Ang ginawa po niya dyan, Henry was the first to wind insulated wires around an iron core. So iron po yung nasa loob niya, to obtain powerful electromagnets. So through coiling, pinaikot-ikot niya yung wire. Pinaikot-ikot. Sana hindi kayo pinaikot-ikot. Ayan. Further, he found that if a single cell is used for a given magnet, the magnet should be wound with several coils of wire in parallel. But if a battery of many cells is used, the magnet winding should be a single long wire. Ano lang naman yun? Kung ano yung ginawa ni Joseph dun sa kanyang early experiments about electromagnetism. So he was the first pioneer when it comes to the study of electromagnetics through the use nga nitong coiling ng mga wires and yung ating iron core. So para ma-appreciate nyo lang yung picture na nakalagay dyan. Okay? Now, we continue with the factors affecting inductance. Bakit natin kailangan malaman to? Kasi yung values ng ating inductance is greatly affected by different parameters na when we are designing such circuits na kailanganan ng inductors, kailangan din nating ma-appreciate or maintindihan at the very least, paano natin mapapataas, paano natin mapapababa, paano natin ma-maintain yung values ng inductance natin. So, for inductors, it will only be able to introduce or to induce a voltage when alternating current passes through the inductor material. So, AC, yung kanya pong ginagamit na current, alternating current, para makapag-induce ng voltage. So kung walang alternating current, kung direct current yung ginamit natin, most likely, wala tayong mapoproduce na or ma-induce na voltahe po dun sa inductor. And again, the higher the inductance, the higher voltage it can produce. So directly proportional po, kung makikita nyo naman dun sa formula natin before, directly proportional yung voltage when it comes to your inductance. So the higher the inductance, the higher the voltage it can produce. Usually, inductors use core to increase its inductance. Mamaya, malalaman pa natin yung mga yan. Ano po yung sinasabi niyo, sir, na core? Para saan po yung core na yan? So this increased the size of the device and is the reason why it is seldom used in timing application circuits. Yung timing application circuits po kasi natin, usually ang kailangan dyan, maliliit lang na components. Malaki tong inductors natin, gawa nga nung core na ginagamit natin. So usually, hindi natin ginagamit yung inductors as timing application circuit. PJ, ayan. Ayan, okay na. Sige. Questions po dito sa slide. Wala naman. Now, we continue. These are your considerations when you are altering the value of your inductance. We have your number of coil turns. Ano po to, sir? Yung inductors natin, actually, it's a coil. Yan, pinaikot-ikot na wire over a certain core. So, kung yung inductor natin, mas marami yung pinaikot mo na coil or mas maraming turns ng coil natin, it's going to produce a larger inductance. So, a greater number of turns represented by N. So, kung mataas yung number of turns mo, it increases the value of inductance. So, mataas din yung value mo ng L. And because your L increases, more voltage can be induced. So, mataas din yung voltage ng inductor natin. Directly proportional silang tatlo. Okay? Next. The diameter of the coil also affects your inductance. Small diameter means low inductance. And kapag mababa ang inductance, mababa din yung voltage natin. Kabaliktaran lang kung malaki yung diameter ng iyong wire na gagamitin ng coil. Ay, sorry. It's this rather pala. You can see it in the illustration, hindi ng wire. Ayan. Kung maliit lang yung diameter ng coil, yung kasi maliit lang yung ikot niya, so maliit lang din yung kanyang inductance. Kung malaki yung coil, yung diameter ng coil, you can see here, malaki yung ano niya, diameter, mataas din yung kanyang inductance. Next, spacing between turns. Ito po yung tinutukoy nun, topmost picture. Yung pagitan po ng mga ikot. Kung mas maluwag yung pagkakaikot niya, wide spacing between turns, low inductance po siya. As you can see in the diagram. And close spacing between turns means it has higher inductance. So to increase your inductance, dapat po mas close yung paikot-ikot nyo. Okay? Size of wire used also affects your inductance. Ano po ibig sabihin nito? Though thickness of wire isn't a parameter for inductance, you may need thicker wire for more current. So mas makapal na wire, syempre, mas malaking kuryente yung pwedeng dumaloy dun sa kuryente. And if there's more current, then the stronger the magnetic field is. Since nakita naman natin yung relationship nun, di ba? Kanina, paano natin din discuss. Kuryente, yung nagproduce ng magnetic field. So, more current, stronger magnetic field, stronger or higher inductance yung maproduce niya. So, the size of wire used affects your inductance. Mas mataas, mas malaki, mas mataas yung kanyang inductance. Kasi more current. Lastly, your type of material inside the coil affects your inductance. So, sir, ano po yung type of material inside the coil? Kasi yung coil natin, meron tayong tinatawag na core, and yung core na yon, that has this property called permeability. So, your inductance increases with the permeability of the core. Sulat lang natin. Permeability. So, the higher, again, may iba tayong core. So, nagdedepende dun sa core na ginagamit natin yung permeability ng material. So, for an air core, halimbawa, pag air po hangin, pwede natin gamitin yung hangin as a core. Pag air, ang R po niya o yung permeability niya is 1. R niya ay 1. With a magnetic core, L is increased by the R factor because the magnetic flux is concentrated in the coil. Hindi man natin masyadong i-delve into tong details na to. At least the basic concept nung factors affecting inductance, maintindihan natin. Pero yung permeability ng core natin, that affects your inductance. Okay? So number of coil turns, diameter of the coil, spacing between turns, your size of wire, and the type of material inside the coil affects your inductance. Questions po? So far, so good? Okay. Next, we proceed with the applications of your inductors. Saan po, sir, ginagamit yung ating mga inductors? First, for resonant circuits. Ano po yung sabihin pag resonant circuits? Mostly yung mga applications po na makikinig nyo sa mas familiar yung mga electronics engineering natin na kasama. Kasi ito yung ginagawa nila. Pero just to give you an overview, ito po yung applications ng ating inductors. Para ma-appreciate nyo naman, sir, discuss ng inductors. Di naman namin alam kung para saan ginagamit. So ito po yun. Start tayo. It is used in resonant circuits. Ano po yung resonant circuits? Dapat ba nagre-resonate yan? Sa ECE po, sa electronics, meron tayong tinatawag na resonant circuit. And yung resonant circuit natin, it's also known as tank circuit, or your LC circuit. LC. LC, parang pamilyar L, na-discuss ko ni sir yung L. Tama. Yung LC, it forms part of the resonant circuit. Ibig sabihin, meron po tayong L, inductor, and C, capacitor. So, pinagsama natin yung inductor and capacitor to form yung resonant circuit natin. This circuit contains an inductor and capacitor attached parallel to each other. The resonant circuits are used to create a particular frequency or to select a particular frequency from a complex circuit. So ito palang resonant circuit, through the use of your capacitor and your inductor, kaya niyang pumili ng certain frequency. Mas maintindihan niyo yan sa next application. Kasi yung next application natin, it's used for tuned circuits in radio reception and broadcasting. Nakatry na ba kayong gumamit ng radyo? Yung lumang radyo Yung radyo kasi ngayon pwede ng online May nakatry na ba? Sa bahay niyo, may mga radyo ba kayo? For sure. Mga magulang natin, mahilig sa ano yan. Mga pangmalakasang sound system. Radio.
Hindi po, sir.
Hindi pa? Masyadong bang millennial yung radyo para sa inyo? Ayan, sige. May nakita naman ako nagta-thumbs up. So, I assume meron namang nakapag-radyo. Yung radyo natin, actually, meron dyang inductors sa loob. Sir, paano po nagkaroon ng radyo? Paano nagkaroon ng inductors yung radyo sa loob? Ano pong gaano niya doon, silbi niya doon? Well, hindi ko naman encourage kayo na sirain yung radyo nyo, pero papaniwalain ko kayo na merong inductor sa loob. Kasi po, si inductor, ginagamit natin siya in tuned circuits. Yung tuned circuits, somehow related siya when it comes to your resonant circuits. Tuned circuits consist of an inductor coil and a capacitor. Sounds familiar, parang resonant circuit Often variable po yung capacitor. Ibig sabihin na babago-bago yung value niya. Para saan naman po yung tuned circuit, sir? A tuned circuit has a very high impedance at its resonant frequency. Resonant frequency. So, almost related nga doon sa resonant circuits. And yung resonant circuits natin, yung tuned circuits natin rather, it's used to select or tune in to radio stations on a particular frequency. Pumipili po siya ng frequency ng radyo. Ibig sabihin, yung nakikinig yung Wish 107.5. Yung 107.5, that's the frequency of your radio actually. 107.5 megahertz. Pinipili yan ng tuned circuits. And yung tuned circuits nyo, may inductors dyan. So that's one of the major applications ng inductors nyo para ma-appreciate nyo naman. So yung papalit-palit na values will make the circuit choose a certain frequency. So pag in-adjust nyo ibig sabihin mag-adjust din yung value ng frequency na kaya niyang makuha. So that's used to tune your radio circuit, reception and broadcasting on a particular frequency, and i-reject niya all others kasi yung frequency natin basically lahat ng frequencies natin, it's over the air. So, kailangan lang may specific na tatanggap and ma-filter out niya yung other frequencies para yun lang yung mapapakinggan mo. So, that's the function of your tuned circuits and inductors in overview in general. Okay? Antenna. Sir, pwede rin palang antenna ang inductors. Actually, hindi siya ganun dalas ginagamit. Pero, just to note, all wires, lahat po ng wires natin have inductance. For example, a monopole antenna, yung monopole antenna po natin is basically an inductor. Monopole, ibig sabihin isang single pole. Malamang sir, mono nga. So, single pole antenna. It has a resonance. Again, bumabalik na naman tayo sa resonance circuits. So, related po sila. Where the capacitance between it and the ground plane cancels out the inductance. At that point, you're basically left with the radiation resistance, which you hopefully can match your source if you want maximum power transfer. So, lahat po ng mga terms na yun, antenna-related terms actually yun. Hindi ko na kayo masyadong ibobore out with that. Pero basically, your inductors can also be used as antennas. Electric transmission. So, ginagamit din po natin si inductors in electric transmission. Inductors are also employed in electrical transmission systems where they are used to limit switching currents and fault currents. In this field, they are more commonly referred to as reactors. So, kung nakakinig kayo, pag trabaho kayo halimbawa sa electrical transmission, most likely hindi kasi pang EE yan, may makikinig kayong mga terminologies, reactors. So, most likely, meron po diyang involved na inductor component sa loob. That's used for electrical transmission. It limits switching currents, and fault currents. So, yan. Next is a filter in power supplies. So, di-design tayo ng power supply, baka magamit natin si inductor. The inductor provides essentially the same function as a capacitor to the voltage, to the current waveform as it stores energy in its magnetic field and releases it back into the output circuit. So katulad din po ni capacitor, kung si capacitor voltage po, si inductor naman, current waveform, yung kanyang pinag-istora ng energy. Then, pabalik sa output circuit. The effect of the inductor storing and releasing energy into the output circuit to provide a slight phase shift, which in turn smooths the area between the current peaks. So current, minamodify niya yung current waveforms natin. That's how you use inductors in power supplies. It smoothens current waveform. Next is a storage device in SMPS. Ano po yung SMPS? It's a switch mode power supply. Switch mode. Ibig sabihin na sa switch. Inductors are typically used as energy storage device in switch mode power devices to produce DC current. So inductors po yung ginagamit natin to produce DC current. The inductor, which stores energy, supplies the energy to the circuit to maintain current flow during off switching period. So kapag naka-off po yung ating switch mode power devices, si inductor yun to supply ng ating DC current. Okay? Audio frequencies, again, we go back to it's almost related dun sa ating first three applications, mga resonant circuits natin. That's how your inductor is being used as audio frequencies. Okay? Malinaw naman po so far? Appreciate naman natin kung para saan ginagamit yung inductors. Ayun. Sige. Punta naman po tayo sa coil. At na-discuss natin kanina, nabanggit ko, kung nakikinig kayo, there's something you call core when it comes to your coils. So, core, coils, mga related yan. Yung core po natin, ano yung nasa gitna ng coil? Saan yung coil? First, we have air core. Pag air, syempre, hangin. Wala kang nilagay sa loob, hangin lang. Sapat na. Ayan. Hangin lang, sapat na. The commonly seen inductor with a simple winding is this air core inductor. This has nothing but air as the core material. Wala kayong dapat tandaan. Air, hangin. These inductors, ano po yung, the goodness behind using air core inductors? These inductors offer a minimum signal loss at the application. So kung ang habol nyo ay signal loss, minimum lang, you could use your air cores, having a very high magnetic field. So that's why mababa lang yung signal loss. Mataas po kasi yung magnetic field strength na in-offer ng air core. Also, there exists no core losses as there is no solid core material. Madidiscuss din natin later on yan, ano ba yung mga core losses na yan. So basically, since wala kang nilagay na core, hangin lang, wala ka ring core loss. So kung gusto mo ng walang core loss, kasi nakaka-apekto po sa performance ng inductor, yung core losses, so you use air core. That's your air core. Mapapansin nyo naman sa pictures natin, so hindi lang po yan for the aesthetic. Ito talaga yung actual pictures natin ng air core. Wala siyang laman. It's hollow inside. It's just pure air inside. Ito po yung iba typical picture ng air core inductors natin. Next, you have your iron or your ferrite iron core. Ferrite iron core. These inductors have ferromagnetic materials such as ferrite or iron as the core material. So may bakal sa loob. May iron. Papansin nyo sa drawing. This is your ferrite iron core. The usage of such core materials help in the increase of inductance due to their high magnetic permeability. So, since iron yung ginagamit na natin as core, mataas kasi yung magnetic permeability ng ating iron core. And kung mataas yung magnetic permeability, mataas din yung kanyang inductance. Na-discuss natin yung relationship na yan kanina. Permeability measures the ability of supporting the formation of magnetic fields. So kung mas mataas po yung permeability, ibig sabihin, mas malakas yung magnetic field na mabubuo. The inductors that have ferromagnetic core materials just like this suffer from core losses. Kung si air core natin, wala siyang core losses, ito, since may nilagay na tayong material, which is yung iron core nga, sa loob, this iron cores, mayroon po yung loss and energy losses, core losses and energy losses, especially at high frequencies. These inductors, though, are usually used in the manufacture of a few types of transformers. Mamaya makikilala pa natin yung mga transformers na yan. So, ayan, para ma-appreciate nyo. But basically, ano pong dapat natin tandaan sa iron core? Sa iron core po, may laman sa loob na ferromagnetic material. Mataas po yung kanyang magnetic permeability. Ibig sabihin, mataas yung inductance na mapuproduce niya. And meron po siyang core losses. So, yun yung mga key natin dito. Key takeaways. May ferromagnetic materials, high magnetic permeability, and yung core losses, meron siyang core losses and energy losses. Okay? So that's your key points when it comes to iron or ferrite iron core. Next, meron po tayong tinatawag naman na toroidal iron core. From the term itself, toroids. Ibig sabihin, meron dyan para pong ring na ginagamit as your core. Iron din siya, pero pinaikot natin yung iron. So, it's a circular iron core. As you can see in the picture here. Ayan. These inductors have a magnetic material as the core substance to which the wire is wound. Again, meron po tayong iron core na ginagamit. These are circular ring shape, in circular ring shape. So, bilog, pinaikot lang. The main advantage of this type of inductors is that due to their circular shape, so may kinalaman po kung bakit natin ginoon toroidal yung gitna, yung iron material. Because yung circular shape, symmetry is achieved in the whole shape of the inductor, due to which there are minimum losses in the magnetic flux. So pag pinaikot natin, it causes the magnetic flux to have minimum losses. So kung ang habol po natin is minimum loss in the magnetic flux, pwede natin gamitin si toroidal iron core. Lastly, these inductors are mostly used in AC circuit applications. So, yan po yung kanyang usage. Saan siya ginagamit? AC circuit applications. Key terms when it comes to your toroidal iron core: circular, ring shape na magnetic material. Then, minimum losses in the magnetic flux. And lastly, AC circuit applications. Yan yung mga tatandaan nyo when it comes to your toroidal iron core. Lastly, ano pa po sir yung types of coil according to core? So, meron po tayong tinatawag na laminated core. Actually, may iba pa, pero di ko na siya sinama dito. Basically, ito lang naman yung typical na ginagamit na inductors. So, last is the laminated core. Laminated, kung mapapansin nyo sa picture, makikita nyo, ang daming layers. Yan po yung mga tinatawag nating laminates. And gawa po yan sa bakal. Yan yung laminated core. These are inductors that have laminated thin steel sheets such as stacks as the core material. So sa halip na buo na iron core yung ginagamit, dito laminated thin steel sheets. So, ano natin, kinompress natin yung steel. Ginawa natin siyang plated. At yun yung ginamit natin as your core. Usually for an inductor, if the loop area is increased for the current to travel, the energy losses will be more. Whereas in these laminated core inductors, thin steel sheets of stacks are helpful in blocking the eddy currents, which minimize the loop action. Mamaya makikilala natin kung anong eddy currents na tinutukoy dito. Pero basically, it's a core loss. And yung core loss na yan, nami-minimize nung laminated core. Pag laminated core, yung ginamit natin na core, type of core for your inductor. It minimizes eddy currents. The main advantage of these inductors is, ayan, ano nga, as mentioned earlier, minimizing the energy loss. So kung ang habol nyo sa design ng circuit nyo is minimal energy loss, so laminated core ang gagamitin natin. These laminated core inductors are mostly used in the manufacture of transformers. Nung gumagawa kami ng power supply before, nung college, share ko lang sa inyo, laminated cores yung ginagamit namin na transformer. Ito yung typical na makikita nyo rin sa mga electronic devices. Hindi yung cellphone na. Siyempre, hindi naman kasya yan. Yung, ano ba maganda? Power supplies, yan. DVD players, alam ko meron yung mga laminated core transformers. TV, sa TV din ata, yung mga lumang TV. Ayan. So, those are your laminated core. Key terms when it comes to your laminated core, syempre, laminated thin steel sheets, yung core material natin, minimize energy loss, mostly used in manufacture of transformers. Okay? That's your laminated core. And those four, yung apat na discuss natin, yan yung mga types of coil according to core. Questions po? All good naman tayo? Okay. We proceed with the next. Ayan, kikilalanin na po natin yung ating mga transformers. May kilala ba kayong transformer? Si Sir, wali na naman po yung joke niya. May kilala ba kayong transformer? Hirap magtrabaho. Optimum Prime. Optimus yun ah. Ba't Optimum Prime? Ano yan, pirated ata yung DVD mo. Ay, nako. Nag-breakfast ka na ba, Jeff? Ayan. Optimum Prime. Ano ba yan? Sino pa? Tigil na nga natin yung joke na to. So, hindi po ito yung transformers na i-discuss natin na. Ang i-discuss natin yung transformer po ay yung ito. So, transformer, it's a passive electronic component that transfers electrical energy from one electrical circuit to another circuit or multiple circuits rather. Again, passive po yan. Passive electronic component pinag-uusapan natin. So, what's with transformer, sir? Magnetic flux is produced by having alternating current flowing in the wire. So, pinapadaanan po natin yung kuryente. Yung kuryente na mention natin kanina, di ba? Yung transformers, alternating current yung pinapadaan niya. Yung alternating current in turn produces magnetic flux. Kaya, magnetic flux yung alternating current nyo. The bigger the magnetic flux, the higher the induced voltage. There are two most used transformer in electronics. Meron po tayong tinatawag na step-up. Hindi po ito yung movie. Step-up and step-down transformers. So from the term itself, pag step-up, pinapataas niya yung ating voltage. Pag step-down, papababain niya yung voltage. From the name itself, you will determine the functions of each transformer. Step down is transferring the higher electrical energy to a lower electrical energy. For example, 220 volts po yung source nyo. Through the use of transformer, kaya nyo pababain into 12 volts. Galing. While the step-up transformer is the opposite of the other. Kabagtaran lang. So, papataasin niya. Kung 12 volts yung voltahe mo, gagawin yung 220 volts or other voltages na required ng inyong circuito. So that's your transformers. Ano pa po yung additional information natin when it comes to your transformers? Transformer, it is a static device which transfers the electrical energy from primary winding. So may tinatawag tayong primary winding pala dito sa transformers to secondary winding. It works on the principle of mutual induction. Transformer allows only alternating current. Again, paulit-ulit po tayo dito. It only allows alternating current. Okay? So, ano po itong primary winding, secondary winding na to? Ano yung relation niya dun sa types ng transformer? So, sa step down, when secondary winding natin is less than the primary winding po, you have your step down. So, mas maraming winding po yung ating primary. That's your step down. Kapag step up, mas marami po yung secondary winding. Kabaliktaran lang. Secondary winding will be more, step up po yan. Secondary winding will be less, step down. Okay? And yan pong windings na yan, may kinalaman sa ating voltahe, sa induced voltage ng transformers. And you can see the relationship here ng turns and induced voltage as Vs, yung voltage natin sa secondary, over yung induced voltage sa primary is equivalent to the number of turns in the secondary winding over the number of turns in the primary winding. So yan lang naman po yung relationship niya. Bs over Bp equals Ns over Np. Okay po tayo sa transformers. Now, meron po tayong iba't ibang uri ng transformers. So, discuss natin sila isa-isa. First is your instrument transformer. Usually, yung mga transformer na babanggitin ko, related siya sa electrical. Pero to give you an overview, ayan, para ma-appreciate yung mga nakikita nyo sa kalsada, sa mga nadadaanan nyo na power plants, ayan, usually sa mga ganito nyo man sila makikita eh. So, discuss lang natin one by one. You have your instrument transformer. These are current and voltage transformation devices that are used to step down the transmission and distribution line voltages and currents to levels that can safely operate measuring instruments, protection devices, and control relays by isolating it from the supply voltage. Hindi ko na masyadong detail out sa inyo. Ayan, nakalagay naman dyan kung para saan gamit yung ating instrument transformer. Meron din tayong power transformers, static machine used to transforming power from one circuit to another without changing frequency, usually used in electric power generation and at distribution stations. Ito, kasi madalas nyo itong makita sa kalsada, yung nakikita yung nakasabit sa poste, distribution transformer po ang tawag doon, or service transformer. It is a transformer that provides the final voltage transformation in the electric power distribution system, stepping down the voltage used in the distribution lines to the level used by customer. So kung dito, sa nauna natin, mataas pa yan, papababain niya, bababa yan ng bababa hanggang umabot niya sa distribution transformer niyo na pwede nang gamitin ng mga end consumer natin. So yan basically yung purpose ng mga transformer in electric transmission. Though meron din sila mga step up, usually mga step down yung para makaabot sa consumer and consumer. You have your single-phase and three-phase transformers. Yung kuryente po kasi natin, meron tayong tinatawag na single-phase and three-phase. Pwede yan tanong sa mga tatay nyo sa bahay. Paano po ba pag single-phase and three-phase? But sa transformers, we have single-phase and three-phase. Single-phase transformers consist of mainly two windings. Dalawa lang. Nakikita nyo to. Yan. Yan po yung mga single-phase transformers natin. One is on the primary side and the other on the secondary side. Three-phase transformers consist of three transformers, either separate or combined with one core. Actually, ito yan. The primary and secondary of the transformer can be independently connected either in star or delta. Electrical engineering terms, so di ko na kayo i-deal with masyado. But yan. Mga nakikita nyo sa poste, yan po yung mga single-phase and three-phase transformers natin. Same. Actually, under siya ng distribution transformers natin. So, meron din po tayong current and potential transformer. Pinagkaiba nila. Current transformer natin, it's a transformer used to reduce or multiply an alternating current. Obviously, current yung involved dun sa current transformer. Binabago niya yung ating alternating current. Potential transformer, voltage naman po yung involved dito. Di ba, tatandaan nyo, voltage is your potential difference. So, yun yung most likely pinaggalingan pangalan niya. Potential transformer, it's a transformer used for the transformation of voltage from a higher value to lower value. Ito yung current, this one, and this is your voltage, potential transformer. Lastly, we have auto transformer. Ito pong auto transformer, pinakababang picture, it's a type of electrical transformer with only one winding. Isa lang po yung winding involved. The auto prefix refers to the single coil acting alone. So, solo mode siya. Greek for self. Not to any automatic mechanism. An auto transformer is similar to a two-winding transformer but varies in the way the primary and secondary winding of the transformer are interrelated. So basically, two-winding transformer siya, pero iba yung terms niya when it comes to primary and secondary winding. Hindi ko na rin kayo with the details with this. At least may surface knowledge tayo when it comes to auto transformer. So that are your types of transformers. You have power, distribution, instrument, single-phase, three-phase, current, potential, and auto transformer. Enumerate po ba ito, sir, sa exam? Hindi. So, huwag nyo nang memoryahin yan. Now, I have questions. All good. Sana, overview lang naman siya, so won't be too much on that. Transformer ratings. So, paano po natin na-identify yung ating gagamitin na transformer? Like other components, transformers have voltage, current, and power ratings. Actually, may frequency pa yan. Nadi-discuss din natin. That must not be exceeded. That must not be exceeded. Tandaan nyo yan, ha? Exceeding any of these ratings will usually destroy the transformer. So, pag sumobra, masama po yun. It will destroy the transformer. Okay, start tayo. Voltage ratings. Manufacturers of transformers always specify the voltage rating. So, typical na to. Makikita nyo yung value nito when you are buying transformer, especially yung mga ginagamit sa power supplies. Naka-indicate po sa mismong power supply yung voltage rating niya. But both primary and secondary windings. Under no circumstances should the primary voltage rating be exceeded. Ayan, nabanggit na nga. In many cases, the rated primary and secondary voltages are printed on the transformer. Nasisira po yung ating transformer pag sobra yung voltage na kanyang application. Okay? You also have your current ratings. Manufacturers of transformers usually specify current ratings only for the secondary windings. If the secondary current is not exceeded, there is no possible way the primary current can be exceeded. If the secondary current exceeds its rated value, excessive I-squared-R losses or power losses will result in the secondary winding. So yan po yung effect kapag yung secondary current nyo exceeds its rated value. Excessive I squared R losses. This will cause the secondary and perhaps the primary to overheat. So sobrang taas ng power, ibig sabihin masyadong mainit. Iinit ng iinit yung ating transformer. And eventually, pag nag-overheat yan, may chance yan na masunog. Overheat and eventually destroying the transformer. Again, pag labis-labis po, masama para sa transformer natin. The IR voltage drop across the secondary windings is the reason that the secondary voltage decreases as the load current increases. Ayun. That's your voltage and current. We also have power ratings and frequency ratings when it comes to your transformer. The power rating of a transformer is the amount of power the transformer can deliver to a resistive load. The power rating is specified in volt amperes rather than watts because the power is not actually dissipated by the transformer. So, hindi po nag-dissipate ng power. Hindi nagpo-produce ng power si transformer. The product VA is called apparent power. So, hindi ko alam kung na-discuss nyo sa electrical engineering nyo, pero meron tayo natawag na apparent power since it is the power that is apparently used by the transformer, kumbaga actual na nagagamit na power ng ating transformer. So, that's your power rating in VA, volt ampere. The amount of power the transformer can deliver, yung actual na nadadala niya sa load. Lastly, we have frequency ratings. Ano naman po itong frequency ratings? All transformers, mayroon po kasi tayong frequency rating na kailangang sundin when it comes to your applications. Typical frequency ratings for power transformers are 50, 60, and 400 Hz. Kapag power transformers po, either 50 or 60 lang siya. Kapag 400 Hz, medyo mataas, ginagamit po siya usually sa mga aircraft. Okay? Yung typical na sa bahay natin, around 60 Hz yan. So, ayun. Okay? That's your transformer ratings. You have your power, your frequency, your voltage, and your current. So, kailangan natin tingnan yan, i-check natin yan, and yung application din natin, yung circuit natin, dapat hindi mag-exceed over those ratings para hindi pumotok or hindi, actually hindi masya puputok, hindi masunog, rather, yung ating transformer na gagamitin. Okay po tayo? Naka-follow through pa naman? Okay. Thank you sa mga nagta-thumbs up. Next. Transformer core losses. Ito na po yung pinag-usapan natin kanina na core losses. Yung material natin sa gitna, yung core, it causes losses dun sa ating, discuss na lang natin. Ayan. You have your eddy current first. Ito yung eddy current na tinutukoy dun sa ating transformer. In any inductance with an iron core, so iron core involved tong eddy current, alternating current induces voltage in the core itself. Since it is a conductor, the iron core has current produced by the induced voltage. Kung natatandaan yung relationship, di ba? Kung hindi gagana yung kuryente kung walang voltahe. Okay? Kasi yung voltahe magtutulak sa kuryente. And yung iron core natin, since merong voltage, meron din yung current na involved. This current is called an eddy current. So yung current na napoproduce ng iron core natin, it's an eddy current because it flows in a circular path through the cross-section of the core. So may ikot-ikot siya dun sa ating core. This eddy current represents wasted power dissipated as heat. So lumalabas siya as heat in the form of heat. In the core, thus the higher the frequency of the alternating current in the inductance, the greater the eddy current loss. So may kinalaman din po yung frequency natin. Mas mataas na frequency ng alternating current, mas mataas po yung eddy current loss natin. So kung iron core, key terms to understand here, to remember, mabilis. Next slide. Ayan. Your eddy currents, meron po yung involved na sa iron core. And yung current na napoproduce sa iron core natin, it's the eddy current flows in a circular path through the cross-section. Higher frequency, higher eddy current loss. So yan po yung mga key terms when it comes to eddy current. Meron din po tayong tinatawag na RF shielding. Yung RF shielding, it's the reason that a coil may have a metal cover, usually copper or aluminum, is to provide a shield against the varying flux of RF current, radio frequency current. Ayan. The shielding effect depends on using a good conductor for the eddy currents produced by the varying flux, rather than magnetic materials used for shielding against static magnetic flux. The shield cover not only isolates the coil from external varying magnetic fields, but also minimizes the effect of the coil's RF current for external circuits. Masyado, sir, technical yung definition. Ano lang po yung dapat kong tandaan when it comes to RF shielding. So, sa RF shielding, ang kailangan lang nating tandaan dito when it comes to your core loss nga na RF shielding, so the key term here is isolates the coil from external varying magnetic fields, minimizes the effect of the coil's RF current. Yan po yung loss na involved when it comes to RF shielding. So yung shield isolates the coil from varying magnetic fields and minimizes the effect of the RF current. Yan lang siguro yung kailangan nyo tandaan when it comes to RF shielding. Hindi natin explain in detail yan. Last loss na di-discuss natin is your transformer, hysteresis loss. Your transformer core na hysteresis. The hysteresis losses result from additional power needed to reverse the magnetic field in magnetic materials in the presence of alternating current. So, additional power needed to reverse the magnetic field. Yan po yung nagkakos ng hysteresis loss natin. Related din po siya sa frequency. So, mas mataas na frequency, more hysteresis losses. Okay? Questions po? Ayan. No questions. We'll proceed with total inductance. Sa resistors, nakita natin paano natin pinagsama-sama yung mga resistors in series, in parallel, meron pang series parallel. Sa capacitance, we've also discussed paano, kabaliktaran siya nung sa resistor. Sa inductance, pag-aralan din natin. So, this is how you compute for your total inductance when it comes to series and parallel connections. Sabi dito, the equation used in finding the total inductance in series is using the format of finding the total resistance in series. Parehas lang po pala, sir. Ibig sabihin, kung yung naka-series, yung inductor mo, katulad lang din siya ng series na resistor. While the parallel inductors use the same format as in the total resistance in parallel. So kung parallel yung inductors mo, katulad lang din po siya ng parallel resistor. Ngayon, since given that information, sino gusto mag-try nung first? Total inductance in series. Volunteer. Tatawag ako kapag wala mag-volunteer. Madali lang yan, series lang. Wala. Okay. Tatawag ako. Oy, may nag-volunteer na. Swerte naman. Maligtas. Ian, take it away.
Ang sagot po, sir, ay 15.
Bakit 15?
Dahil po since series lang din po siya ng resistance sa total inductance po. Pinag-add ko po yung 5 and 10.
Amazing. Ang simple lang, di ba? 5 and... wait, anong label nung... Label. Anong meron doon sa 15? Anong label niya? 15 ohms.
Ang Henry nga.
Henry. Yan.
Ay, millihenry po.
Yan. Sige, thank you. So 15 millihenry. Huwag niyo kalimutan yung millihenry ha. Baka kung anong 15 yan eh. Don't forget the label ng ating value. So 15 millihenries. Again, typical value ng ating inductors, milli lang, millihenry or microhenry, kung natatandaan niyo sa una. So that's 15 millihenries. Pag-adin lang po natin, since katulad lang din pala siya ng series resistors. So that's, wait lang. Ayun, mali pa rin sinusulatan ko. 5 plus 10 lang. So 15 millihenry. So L1 plus L2 for your total inductance. Sino pong gusto mag-try ng total inductance in parallel? Ay, Angel. Si Angel na una. Okay, go.
Ano po, bale 1.6 millihenry po.
1.6 millihenry?
Yes po.
Sure ka na?
Yes po.
Natawa. So, sino parehas yung sagot kay Angel? 1.6 millihenry. Taas kamay. Yan, taas nga silang kamay. Sige. Amazing. Kung 1.6 millihenry yung sagot nyo, mali. Hindi, joke lang. Tama. Tama yung 1.6 millihenry. So again, paano tayo kumukuha ng resistors in parallel? Reciprocal lang, di ba? 1 over L1, or in this case, 1 over L3. Ang bagal ng pen ko, sorry. Plus 1 over L4. Your total inductance will be 1.6 millihenry. Ayan. Okay? Questions po? Madali lang, sir, no? Kayang-kaya. Bakit subtitles? Ayan. Jonel, may question ka?
Sir, may tanong lang po ako.
Yes.
Di ba po ang inductance po at capacitance ay parang pareho po? Ay bakit po yung ginamit na formula ay kagaya na sa resistance?
Yung sinasabi na, thank you, magandang tanong. Yung sinasabi nating parehas lang, yung capacitor inductance natin, it's more on their properties. Hindi necessarily na dito sa application natin, which is yung paghanap ng total inductance. It's a different, parang oranges and apples yan. It's a different story. Hindi ibig sabihin na, ibig mo ba sabihin, okay, wait. Dahil ba sa resistor natin kinumpare yung inductance? Dapat ba sa capacitor? Parang ganun?
Opo, yung pong formula.
Again, ayun. Oranges and apple. Ang pinag-uusapan nating pagkakaparehas ng inductors and capacitors is the way they store energy. More on the storage of energy. Ibang usapan when it comes to finding their total inductance and total capacitances. Ayun. So, not necessarily, it doesn't translate directly na, kumbaga may exception to the rule. Ayun. Sana nasagot ko yung tanong mo.
Opo, thank you po.
Ayun. So, wag kayo malilito, not necessarily na pinag-usapan natin na parehas sila, parehas na rin lahat. Diba? Ayun. So, magbigay ng maganda example pero I hope you get the thought na hindi lahat nung is parehas when it comes to comparing capacitors and inductors. Anyways, questions pa? Thank you, Jonel. Gandang tanong. All good. So, we'll be proceeding with, patapos na tayo sa Module 3. Ayan, time constant using inductors. So, sa inductors po, meron din tayo tinatawag na time constant. Since parehas lang siya ng capacitor na meron tayong hindi man charging and discharging. May, in a way, similar to sa charging and discharging. Since nakapag-store nga siya ng energy, so the waveform for charging process is a rise curve, and the discharging has a decay curve, yung pataas and yung pababa na nakita nyo before sa capacitors. Ganun lang din po halos yung sa ating inductors. Yan. Ito yung rising niya, ito yung decay. Dito pala dapat. The percentage are also the same as in the universal time constant graph in capacitors. For the first constant, it gains 63%. So may 5 time constants din po tayo when it comes to your inductors. Second time constant, 86. Third, 96. Fourth, 98. Until the fifth time constant, almost 100% yung kanyang pag-charge. Ayan. As you can see here, it also uses the 5 time constant to have the supply voltage be totally induced in the inductor. That's your time constant in inductors. Ito, meron din tayong inductor coding actually when it comes to your inductors. Nasa huli. Nung capacitor and resistor, nasa unahan yung topic ng inductor coding eh. Kasi sa inductor, wala tayong masyadong dito. Wala masyadong generally standardization when it comes to your coding of inductors. Pero, sige, let's take a brief overview when it comes to your inductor coding. Since though wala naman siyang standard na usually pinapractice, still, we have the coding. Inductors may or may not be coded to indicate their inductance value in henries, millihenries, or microhenries. Some very small inductors used in RF circuits may consist of 5 or 6 turns of bare wire lang and therefore cannot be coded. Imagine nyo, sobrang liit na nga nun, lalagyan mo pa ng code. Tapos, wire pa yung gamit na material, di ba? Bare wire. So, paano sulatan yung bare wire? Kaya, medyo magulo yan when it comes to coding. Larger inductors, meanwhile, such as chokes. Chokes po is, para siyang toroidal na inductor. Paikot din siya. Used in the audio frequency range, normally have their inductance values printed on them. So, may pagsusulatan. So, nakalagay na directly yung inductance values. In this case, though, where coding system similar to that used with film capacitors, kung ito man, yung ma-encounter nyo na inductor, may code. Usually, ang ginagamit dito, katulad sa film capacitors, may 3-digit coding tayo used to indicate the inductance value in microhenries. So, microhenries po yung ginagamit nating value. For example, an inductor may be coded 103. Ano po yung 103? First 2 digits, again, that's your significant digits ng value ng inductance. So that's 10. The last digit, called the multiplier digit, again, the third is your multiplier, tells how many zeros to add after the first 2 digits. So you just multiply 10 by 10 raised to the 3. That's 1,000. And therefore, your inductance would be 10,000 microhenries. Yun lang po yun. Madali lang, di ba? Usually, the 3-digit code includes no tolerance rating. Sometimes, inductors have their value printed on the body. Sometimes, they have colored stripes. And sometimes, they are not coded at all. Nakakalito, no? Yung iba, nakaprint. Yung iba, may colored stripes, parang resistor. Yung iba, walang code. Paano ka ng inductor coding kung hindi ganun ka specific or ayos? Actually, yun talaga yung nature when it comes to coding inductors. The only sure way to determine the value of the inductor is to measure its actual value. Sukatin natin mismo yung value niya. Kasi nga, as mentioned earlier, no standardization is being used in place for the coding of inductors natin. And since wala nang standardization, will not deal much of inductor coding unlike the sa capacitors and resistors. Ito lang yun. Very overview lang. Okay? Malinaw po? paiba-iba sila. So, walang standard. Kaya, yun lang. And the final topic would be troubleshooting your transformers and your inductors. So, ito na yung last. Sa transformers, we have yung tinatawag nating cold check and hot check. Kapag cold check po ang ating ginawa sa ating transformers, without applying voltage to transformer and measuring the resistance of each winding, then determining the primary and second wind. Ha? Ano sabi niyo, sir? Walang voltage po na involved sa cold check. Yun lang yun. Without applying voltage. Tsaka siya magsusukat ng resistance. Kapag hot check, kabaliktaran niya with voltage. Siyempre, may voltage, may kuryente. Kaya hot. Kapag cold, wala na yan. Okay? Yun lang yun. Easy. Next, your inductors. The most common trouble in coils is an open winding. So, sa inductor, meron din po tayong tinatawag na open. And open winding yung common na trouble sa inductors natin. An ohmmeter connected across the coil reads infinite resistance. So, kapag sinukat pala natin with the use of an ohmmeter or a multimeter set into measuring the resistance, infinite yung makukuha niyang value kapag open. So, key terms to your inductor troubleshooting, pag open, infinite. Open, infinite. It does not matter whether the coil has an air core or an iron core. Since the coil is open, it cannot conduct current and therefore has no inductance because it cannot produce induced voltage. Okay? So, kahit anumang material yung nasa gitna ng ating loop, ng ating core, ng ating coil rather, open kasi siya. So, ibig sabihin, wala pa rin siyang mapuproduce na kuryente. When the resistance is checked, the coil should be disconnected from the external circuit to eliminate any parallel paths that could affect the resistance reading. So, just one thing to remember, pag susukatin po natin yung resistance, hindi natin directly i-connect dun sa coil, dapat naka-disconnect muna siya sa ibang sirkito. So, tanggalin nyo sa pagkaka-connect. Now, these are the usual troubles when it comes to your inductor. Direct current resistance of a coil, an open coil, your value of inductors can change, open primary winding sa transformers, open secondary winding, again, this is for transformers, short across secondary winding, it's described naman there. Garikon nyo. Naka-describe naman dyan kung ano yung mga yan, mga troubles na yan. You could just check out kung ano yung problema kapag may direct current resistance sa coil, pag may open coil, kapag value change, ano yung self-explanatory, nagbabago yung value natin over time ng inductor due to ito, mga causes na to, core breakage, windings, relaxing or shorter turns. Open primary winding sa transformer, secondary winding yung pagkakaloop ng ating coils, naging open, so ano yung maging epekto, and pwede rin siyang shorted. So those are your troubles, common troubles in inductors. And that's it. That's your introduction to passive electronic components. We've all discussed your resistors, capacitors, and inductors. Thank you for listening. Any questions? All good? Medyo mabilis po yung sa troubleshooting. I let you read on those topics para basahin yung module niyo. Questions po?
Wala naman po, sir.
Thank you, Cloud. If wala na, I'll give you... Oh, Jeff, may pahabol. Sige. Go, push.
Sir, may tanong lang po. Curious lang po.
Sige.
Di ba po, sir, sa mga linya ng kuryente, pag po naputol ay may nalabas na kuryente. Yung parang lightning. Parang may parang may nakita po ako na hinahawakan po mismo yung parang nalabas na kuryenteng yan. Possible po ba sa dyan na pwede po yung mahawakan?
Sa TikTok mo ba yung nakita? Sa Facebook?
No po, sa Facebook po, sir. Pero nakatungtong po siya sa bangko. Parang nag-aayos po siya sa dyan.
Sige, good question. Una, huwag gagawin kung hindi alam kung ano yung gagawin. Huwag niyong gagayahin, okay? Word of a reminder lang. Pero, yes, it is possible, hindi yan edited. Bare hands ba yung gamit? Sorry, di ko pa napapan. Parang napan ko yung video, di ko lang.
Opo, sir. Bare hands po.
It has something to do with grounding. Kapag kasi grounded yung way ng pagkakahawak mo dun sa transmission line, feeling ko transmission line yung hinahawakan niyo eh. And bare hands lang bare hands. Kung may protection kasi yan, so walang problema. May gloves, safety gloves or whatsoever. Okay yan. Wala mang kuryenteng dadali sa'yo. Feeling ko, it all relates with grounding. Kasi kung may ground ka while doing that activity, hindi dadaloy sa'yo yung kuryente. Rather, dadaloy siya dun sa ground. Yun yung purpose ng grounding natin. So, feeling ko either may grounding siyang nakalagay and siguro sa kanya, sa kanya mismo, sa sinusuot or what. Pero, ayun, I think it's the grounding that makes it happen na hindi siya nakakuryente. Possible siya, pero, ayun, wag niyong gagawin kung hindi niyo, hindi kayo aware. How does it work? It's caused by the grounding.
Thank you po.
Doon pupunta yung kuryente sa halip na sa kanya.
Thank you po, sir.
Sana sagutin tanong mo. Sige. May question pa ba kayo? Nakatawa yung tanong niya, out of curiosity. May question pa kayo? Ayun. If we're all goods, 2-minute break tayo. We'll proceed with our next topic for fourth module. We'll start the fourth module. Already available in your Google Classroom for your reference. See you in 2 minutes. Break muna tayo, guys. Ayun. 2 minutes is done. Sana nakapag-water break kayo, nakapag-CR break. We'll be continuing our discussion with the fourth module about introduction to conductors and insulators. So this is just a short discussion. Sana matapos natin before 10 about your wire conductors, insulators, switches, and fuses. Actually, by the way pala, your midterm exams will just cover until Module 3. Ito would start na yung sa final examinations niya about introduction to conductors and insulators. Sa last na to part. We'll just be starting off early para makahabol tayo dun sa ating topics. Okay?
Okay po, sir.
Ayan. Nandiyan pa naman lahat? Kahit na 32 na lang kayo. Ayan. Pa-32 na lang kayo. Parang munti kayo. Okay. We'll be continuing with introduction to conductors and insulators. Ano po yung pag-aaralan natin, sir? Dito. In this chapter, you will be introduced to a variety of topics that includes wire conductors, insulators, connectors, mechanical switches, and fuses. So ito yung mga hindi natin masyadong napapansin na when it comes to your circuits. All of these topics relate to the discussion of conductors and insulators. Bakit? They either pass or prevent the flow of electricity. So sila po yung nagpapa-stop and go ng daloy ng kuryente. So discuss din natin sila kasi mahalaga silang part ng ating serkito depending on their condition of state. Ayan. Ano yung objectives natin by the end of this module? You should be able to explain the main function of a conductor in an electric circuit. Para saan po si conductor? Define the importance of wires. Know its cross-sectional area, types and advantages, and common types of connectors. Malalaman natin yan mamaya kung ano yung mga connectors na yan. Ano yung mga wires na usually natin ginagamit. Define switches and identify its types and functions. So, hindi lang kayo basta patay buhay. Nung mga nakikita nyo sa bahay, aalamin natin kung ano yung mga patay buhay na yan. Define fuses and identify its types and functions. Familiar ba kayo sa fuse? Nakinig nyo na ba yung fuse? Uy, may mga familiar.
Yes po.
Mukhang taong mahilig magboting-teng. So, ano din natin yan? Pakialamanan din natin yung mga yan. Define insulators and be able to identify its characteristics and examples. So, ano po yung mga insulators na yan? Parang, since nag-discuss tayo ng capacitors and capacitance, and important sa component nila, yung insulators, discuss lang din natin ng maikli kung ano yung mga yan. No basic troubleshooting procedures for connectors, wires, and switches. So, malalaman din natin paano po inaayos yung mga sirang connectors, sirang wires, sirang switches. Ayan. That's your objective by the end of this module. Now, we start with the function of your conductor. Paano po gumagana or para saan ba yung ating conductor? The key phrase here is that conductors delivers energy from the source to the load with minimum loss. Delivers energy. Di pala ako nakapen. So, it delivers energy with minimum loss by the electron flow. Dumadaloy po yung kuryente natin sa conductor and trabaho ng conductor na dalhin yung kuryente na yon with minimum loss. Example, meron tayong circuito dito na nakakonect sa 120 volts na source. As you can see here sa diagram, and may load tayo na 100 watts na bumbilya. Typical na nakikita natin sa bahay pag nagbukas tayo ng ilaw. Yan, nakakonect yan through a copper wire conductor. Assume natin, 10 feet ang haba. So, the resistance of the 2 feet to 10 feet lengths of copper wire. Ito po yung una, yung connection niya from this side, and the connection from this side is the other one. Assume na meron tayong 2 10 feet lengths ng copper wire conductor. Yung resistance po niya, makakompute natin as 0.08. Saan po galing 0.08, sir? Ba't bigla ka nagbigay ng random na value? Yan po yung typical resistance ng natin, conductor wire. So, 0.04 ohms. Since naka-series lang naman siya, pag-add lang natin, total resistance niya ng dalawang wire ay 0.08. Okay? Yung resistance na yan, 0.08 ohms, napakaliit lang compared do sa 144 ohms ng bumbilya natin. Yung resistance nandun sa bumbilya. Saan po galing 143 ohms? Low lang po yan. Makukuha nyo na yung value ng 143, yung total resistance. Naka-series lang yan. So, either way. Anyway, yung value niya ng resistance is 143 ohms. Napakalaki compared dun sa 0.08 na resistance ng ating wire. Okay? When the current of 0.833 amperes, may dumaloy na kuryente. Again, ohms law lang po yan. Flows in the bulb and the series conductors, the IR voltage drop of the conductors is only 0.07. Kung may dumaloy pong kuryente, dun sa wires, ang value lang ng voltage niya is 0.07 volts. Whereas, yung sa bumbilya, ang makukuha niyang voltahe, since naka-series siya, total sum ng voltages, less lang natin yung 0.07 sa 120, makuha natin yung value ng voltage niya is around 119 volts. Nasa kanya lahat ng voltahe nung ating circuito, nung source. Sa kanya mapupunta halos lahat. Dumaan lang yung, may malit lang na voltage across the conductors. Pero most of it will go to the bulb. Practically all the apply voltage is across the bulb filament, do sa filament specifically. Since the bulb then has its rated voltage of 120 volts, approximately, it will dissipate the rated power of 100 watts. Since na-achieve natin yung delivery ng voltage, kasi ang rated voltage ng watts is 120 volts. Approximately, ma-achieve din natin yung 100 watts niya na power delivered. Kasi na-deliver natin yung 120 volts. So, maganda yung ilaw natin. Full yung ilaw. Sobrang liwanag. Ano lang yung gusto nating ipakita doon sa ginawa kong, sinasabi ko sa inyong example, itong mga pinagsasabi ko. The IR voltage drop, yung current time resistance voltage drop natin in the conductor is practically zero because its R is almost zero. Walang negligible yung voltage drop. Ibig sabihin, sinasalo lahat ng bumbilya yung voltahe. Kapag ganito yung nangyayari, when it comes to your circuits, basic electrical circuits, for this example, the conductor delivers energy from the source to the load with minimum loss by electron flow in the copper. It suits the function of the conductor. Ibig sabihin, conductor yung ating wires na dinadaanan. Kumbaga, na-achieve ng conductor, yung pagiging conductor niya. Kasi it delivers energy from the source, yung 120 volts natin na ibigay niya doon sa load natin na bumbilya with minimum loss. Minimum loss kasi na-achieve pa rin niya yung almost yung rated voltage, yung 119 volts. Therefore, maganda yung ilaw ng bumbilya. Yan yung function ng ating conductor. Dalhin yung kuryente papunta sa load with minimum loss. Okay? Ang haba ng explanation ko, but basically, that's the gist of it. That's how your conductor works. Delivers energy with minimum loss. Questions? All good? Okay. And with your conductors, yan po yung ginagamit natin sa ating wires. Familiar mo kayo sa wire, no? So, we have standard wire gauge sizes po. At yung gauge numbers na ginagamit usually is from the American wire gauge or Brown and Sharp gauge specifics. It specifies the size of round wire in terms of its diameter po. Diameter. Doon natin nalalaman yung ating wire na gagamitin and cross-sectional area. Yan. Yung important factors niyan. Please note lang the following 3 points. As the gauge number increases from 1 to 40, the diameter and circular area decrease. So, inversely proportional yan. Habang tumataas, yung number natin, bumababa po yung diameter and circular area niya. Higher gauge number indicates thinner wire sizes. So, kung 40 yan, ibig sabihin manipis lang yung wire. Kung pupunta po kayo ng hardware store, tatanungin kayo kung anong wire yung kailangan nyo, anong size. So, yan yung sasabihin nyo. Kung maliit, usually mataas yung value. Kung malaki, mababa lang yung value ng wire. The circular area doubles for every 3 gauge sizes. For example, number 10 wire has approximately twice the area of the number 13 wire. So, kada tatlong talon ng size, nagdodoble po yung area niya. Okay? The higher the gauge number and the thinner the wire, the greater the resistance of the wire for any given length. In typical applications po, at least for the electronic components, mga electronic circuits natin, ang ginagamit po natin, since milliamperes lang naman, di ba? Yung values na pinaglalaroan natin, 22, size 22 yung ginagamit natin dyan, na wire gauge. So this size can contain a maximum current of 0.5 to 1 ampere. Yan, typical na yan for your electronic circuit. So size 22. House wiring, pag sa bahay, so ito, elect circuit. circuits. Pag housing, circuits, house wiring, yan. Typical dyan, 5 to 15 amperes. So, 14 yung gauge. Number 14. Minimum size for house wiring are set by the local electrical code. So, meron tayong tinatawag na Philippine Electrical Code. Yan yung pinagbabasihan natin, naging standard natin when it comes to deployment of your wires, especially sa mga construction ng house wiring, building wirings, mga electrical wirings natin. Okay? Yung standard wire gauge sizes natin, you can see here in the table, detailed. Kapag 1, ayan yung diameter niya in mils, area is circular mils, your ohms per 100 feet, ayan, mga details lang naman siya ng wire. Para makita nyo lang kung paano nagbabago yung values as the gauge number changes as well. Please take note, 1 circular mil is the cross-sectional area of a wire with a diameter of 1 mil. The number of circular mils is in any circular area is equal to the square of the diameter in mils or C mil, D squared ng mils. Ano po yung pinagsasasabi niyo, sir? Itong diameter na data dito, actually, kung i-check nyo, para makuha yung area niya in circular mils, square nyo lang po to. Raise nyo to the second power. Lahat ng values na yan. Square lang po nito. So, 17.90 squared is equivalent to 320.4. Yan po ipagkuha natin ng area in circular mils. So, kung required na hanapin yung circular mils, you just square yung diameter mils. Okay? Question? All good? We proceed with your types of wire conductors. Ano po yung mga iba't ibang wires na nakikita natin? Most wire conductors are copper. So, tanda, na-discuss natin to early on, di ba? Wire conductors usually ginagamit natin. And due to its low cost, copper yung ginagamit natin na material. Pwede rin silver, pwede rin aluminum, pero mas mahal kasi ang mga yan. The copper may be tinned with a thin coating of solder. Tanda ko nyo pa kung ano yung soldering tin natin. So, binabalutan siya yung wires natin. Para lang madaling hinangan, which gives it a silvery appearance. Thin wire is easier to solder for connection, especially pag mga electronic circuits po yung ating pinag-uusapan. Nilalagyan ng hinang yung ating wire para mas madaling dumikit. A, B, C, D, E, ano po yung mga yan? Isa-isahin natin. Una, solid wire. Ito po yung letter A. Pag solid wire, ibig sabihin, solid yung ating wire. Pinagsasabi mo, sir. Ibig sabihin, buo yung nasa loob ng insulating material niya. Buo lang yung wire. Solid wire is made of only one conductor. If bent or flexed repeatedly, the solid wire may break. So, in-applyan nyo ng stress, kung paulit-ulit, na-stress out yung wire, mapuputol din siya eventually. May break. Therefore, solid wire is used in places where bending and flexing is not encountered. So, please take note of that. Kapag may bending and flexing, as much as possible, we don't use yung solid wire kasi may tendency siya na maputol and hindi gumana yung pinaka-purpose niya as wire conductor. House wiring is a good example of the use of solid wire. So, kung i-check nyo yung wiring nyo sa bahay, usually po, typically, solid wires yung ating ginagamit dyan. Huwag nyo nang buksan kasi may live na kuryente dyan. Pero, solid wire yan. Kahit itanong nyo pa sa tatay nyo. Okay? So, that's your solid wire. Single strand. Kapag stranded naman po, hindi po yan naiwan or na-stuck sa kung anumang lugar. Hindi po siya na-stranded. Stranded, ibig sabihin, marami pong several individual strands. Madami. Nakakita naman kayo siguro ng ganito, no? Usually, ginagamit natin siya for telephone cords, extension cords, speaker wire. Few applications niyan, mga stranded wires natin. It's flexible, easier to handle, and less likely to develop an open break. Kasi po, ang daming wires na individual pieces of wires, mga conductors na nasa loob. Kahit maputol yung isa, pwede pa rin dumaloy dun sa ibang conductors natin, yung kuryente. Sizes for stranded wire are equivalent to the sum of the areas for the individual strands. So, yung isa-isang area ng strand, kada strand niyan, pag pinagkumpul-kumpul mo, yun po yung size, yun yung magdedetermine ng size ng stranded wire natin. Yung total ng mga individual strands niya. Okay? Yan po yung ating stranded na wire. Next, braided. Braided, ibig sabihin, tinirentas. Makikita nyo naman ng itsura, parang tinirentas nga po siya, sir. So that's your braided conductor. The braided conductor is used for very low resistance applications. It is wide for low R and malapad siya. Kaya makikita nyo, malapad siya kasi para makuha yung low resistance. And thin, manipis lang din for flexibility para madali namang bali-baliin or paikot, i-shape out. And the braiding provides many strands. A common application is a grounding connection which must have a very low resistance. So sa grounding po yung typical applications ng braided conductor. Next, D at E. Yung nakikita nyo sa letter D and letter E, that's your transmission lines. Ano po yung transmission line, sir? Constant spacing between two conductors through the entire length provides a transmission line. Common examples are your coax cable. Yung coax cable po natin yung nakikita natin sa mga cable. Kapag naka-cable yung television nyo, tanggalin nyo yung kable sa likod ng TV, coax po yun. Coax cable transmission line. Etong isa, usually twin LED ang tawag po dyan, yung letter E. Twin LED, ibig sabihin, dalawang separate na LED cables, kita nyo naman, magkahiwalay, may ginagamit na material between them. Usually, ang tanda kong application nito is for your antennas in connection, diretso connection sa radyo. Lumang-luma na yun, hindi ko alam kung familiar pa kayo doon, pero yan. Doon ko siya na-encounter, yung twin LED cables na yan. Ayan. Makikita nyo coax cable used for signals in cable television. Pag nga naka-cut kayo, naka-cable TV kayo, yan yung ginagamit typically na connection para magkaroon kayo ng cable. Okay? Then, yung twin LED naman, to wire conductors embedded in plastic provide constant spacing. Usually, ayun, connecting antenna nga to the receiver. Tama pala yung natatandaan ko. So, that's your application of your transmission lines. Yan gamit natin to transmit information. Usually. Yan din po transmission lines ginagamit natin para mag-internet kayo. Para mag-internet tayong lahat. Kami, nag-work kami sa telecommunications company. So, we use transmission lines para ma-deliver yung internet from one point to another. Ayan, mga typical applications. Meron din po tayong tinatawag na wire cable. Wire cables, these are two or more conductors in a common covering form a cable. Each wire is insulated from the others. Cables often consist of 2, 3, 10, or many more pairs of conductors, usually color-coded to help identify the conductors at both ends of the cable. Typical, makikita natin to sa, ito, for example, itong ribbon cable natin, multiple conductors yan. Makita nyo naman, ang daming linya na separately covered with, separately insulated from each other. Ito makikita natin usually sa mga computers, computer cables. So that's your wire cable. And basically, yan yung mga common types of wire conductors natin. Questions po? Nakasunod naman? Yon. Sige. Thank you sa mga nagka-thumbs up. At least na naka-recognize na okay tayo. Then, we have your connectors. Connectors, syempre, nagko-connect yan. May kino-connect yan from one point to another. And you have this common types of connectors natin. You have your A, B, C, D, E, F, G, H, I. Isa-isayin natin. Si A, yung tinatawag po nating spade lug. Si B, yung tinatawag nating alligator clip. Si C, si double banana pin plug. Si E, RCA type plug for audio cables. So kung nag-aano kayo ng mga DVD players dati, RCA, yan yun. Si F, pag mahilig kayo ito usually sa video, sa mga microphones. Ang tawag po dyan, phone plug. Yung G natin is your F-type plug for cable TV. Again, pag patanggalin nyo nasa likuran, yung makikita nyo yan, F-type plug po ang tawag dyan. And yung H is your multiple pin connector plug. Ibig sabihin, marami po yung pin sa loob. I think this is a VGA. Yung example natin. Generally, it's called multiple pin connector plug. And yung lastly, yung spring-loaded metal hook as grabber for temporary connection and testing circuits. Isasayin po natin itong mga connectors natin. Spade lug, it's often used for screw-type terminals. So, madalas makikita nyo to pag wiring ng mga sa mga main distribution panels ng bahay nyo, mga main distribution boards. Spade lugs yung ginagamit niya to connect yung mga wires. Yan yung spade lug. Alligator clip, ito sa kuryente din yung madalas. Sa mga laboratories nyo, ito rin yung ginagamit. Pang-clip sa baterya, sa mga high-power devices. Ayan. It's convenient for a temporary connection lang. Kayang tanggalin agad. Kaya usually ito yung ginagamit sa experiments para pag lilipat mo, madali mong mailipat. Alligator clips come in small and large sizes. So kung mas malaki yung kailangan i-clip, mas malaki yung kailangan na alligator clip. Banana pins. These are your connectors that have spring type sides to make a tight connection. So may spring po siya sa gilid para maging secured, lalong secured yung ating connection. Terminal strip, it provides a block for multiple solder connections. So kung marami yung kailangang i-connect na circuits or wirings, so you use your terminal strip. Kikita nyo naman siya dun sa ating illustration, di ba? Isa lang yung source, yung main connection niya, tapos marami yung magbe-benefit dun sa source na yon. So you use your terminals. You have also your RCA type plug. It's commonly used for shielded cables with audio equipment. So, ayun nga, pag mga audio na, you have your RCA. Pag mga nag-check din kayo sa hardware stores, yan, tinatanong yan, RCA ba yung gagamitin mo? The inner conductor of the shielded cable is connected to the center pin of the plug, and the cable braid is off connected to the shield. Both connections must be soldered. Yung phone plug naman po natin, it's still used in many applications, but usually in smaller sizes. Actually, yung phone plug, ito rin yung ginagamit nyo if your headset, yung mga earphones nyo, yan, na pumapasok sa phone, that's your phone plug. Or audio din. That's a smaller version para makakinig kayo ng mga audio nyo. Yan, that's phone plug. The ring is insulated from the sleeve to provide for 2 connections. There may be a separate tip, ring, and sleeve for 3 connections. The sleeve is usually the ground side. Yeah. That's your phone plug. You also have your F connector. Your F connector, it's the universally used in cable television because of its convenience. The center conductor of the coaxial cable serves as the center pin of the plug so that no soldering is needed. Also, the shield on the plug is press fit onto the braid of the cable underneath the plastic jacket. So that's your F connector. Ginagamit po sa cable, Cat B din, yung application niya. Multiple pin, these are used to connect your components sa computer system. Usually nga sa yung mga VGA cables natin. So that's your multiple pin connector para i-connect yung desktop monitor mo sa CPU. Spring-loaded metal hook, it acts as a grabber for a temporary connection to a circuit. Usually, makikita natin siya sa VOM or VMM, mga multimeters. So, yun po yung mga common connectors natin. Do you have any questions? Ano lang po naman to? Overview lang. Para ma-familiarize kayo kung ano ba yung tawag sa mga connectors na typically ginagamit natin. Kung walang questions, we proceed with your printed wiring boards or your PCBs, printed circuit boards. Most electronic circuits are mounted on a plastic or fiberglass insulating board with printed wiring. This is your printed circuit or printed wiring board. One side has a component such as the resistors, capacitors, coils. So lahat ng mga components natin nasa isang side. The other side, nandiyan naman po yung conducting paths. So nandito sa ibabaw, sa isang part, sa ibabaw yung natin, mga components, nasa kabila naman yung connections niya. So nakikita nyo, may mga hinang dyan, may mga connections, itong mga to. Yan, that's your printed wiring boards. The conducting paths printed with silver or copper on the board instead of using wires. So hindi po tayo gumagamit ng wires usually kapag nag-ano tayo ng printed circuit or printed wiring boards. Yung connections niya, naka-connect na po siya through this, itong connection na nakikita nyo, itong mga guhit-guhit na to. Connected na po yan. Gawa po yan sa either copper or silver. And yung pagkakahinang niyan, halimbawa ito, Ito, papunta dito. Ayan. Connected na siya through that silver or copper on the board, yung conducting paths niya. On a double-sided board, the component side also has printed wiring. Pwedeng ganun. May printed, may wiring din when it comes to the other side. Pag double purpose or double-sided yung board nyo. Sockets, small metal eyelets, or holes in the board are used to connect the components to the wiring. Ayan. Mas ma-appreciate nyo to, I guess, when you design your own printed circuit board through the use of Target. Actually, yun yung purpose ng Target nyo na software, to make a printed circuit board gamit yung diagram. Ano natin yan, ma-explore natin yan next month. Since out of time na tayo, ang haba ng discussion natin kanina ng introduction. Apologies for that. Pero ayun, may pending pa tayo about switches, your fuses, and your troubleshooting and insulators. So continue lang natin for the next discussion. Do you have questions for now? Doon sa mga na-discuss natin? Wala naman.
Wala naman po, sir.
Okay. Hopefully intindihan nyo man, appreciate nyo yung topics natin about inductors and your insulate. Una pa lang, conductors and connectors. So we'll be continuing it on our next discussion. But for now, I'd like to remind you na next week, on Monday, you'll be having your first quiz. Ano po sir yung coverage? It covers the first 3 modules about the basic electronics introduction, electricity introduction, test equipments, and software familiarization, and lastly, itong passive components natin. It's an online quiz. So, ayan. Questions? On Monday to Alam ko may activity ata ng Monday, pero ayun, let me know lang kung may magkakaroon ulit ng conflict sa schedule. Alam ko may activity sa Monday, pero tama ba? May activity sa Monday. Morning lang ata yung nakitang program eh. Aware ba kayo?
Hindi po.
Hindi. Or baka sa faculty lang siguro. Anyways. Ni intramural sort of kind ata ako nakitang announcement sa group. Pero ayun, kung wala naman, sige, much better, makapag tayo. Quiz and laboratory next week. So that's what's scheduled for Monday. Okay? Yes, Jeff.
Sir, di lang po nakapag-attendance po. Baka po, sir.
See you next sem. Sige, noted. Ba't ka pag na-attendance?
Hindi po, sir, ako nag-isip.
Sorry?
Ano po, sir, hindi po ako nakagising.
Yep na naman.
Sir, ako din po, hindi rin po nakapag-attend.
Ikaw din?
Opo.
No, see you next time din. Sige, noted. Late kayo
Opo, sir.
Sige, ayun. Noted. Hindi kayo absent, pero late kayo. May questions pa? If wala na questions, thank you for your participation. Thank you for your candidness today. Sana may natutunan kayo. Happy Saturday, guys. Bye-bye.
Sige po.
Prepare for your quiz. Prepare for
Sige
your
po,
quiz.
sir.